Hello guys, welcome to another video. Today we are going to solve Unit 1, January 2025, because I felt that I was being biased towards Unit 3 and I should do some other unit. So, starting with question 1, I'll zoom it out a bit. Okay, stress is applied to a sample of a material. The stress is increased until the sample breaks. The graph shows the relationship between stress and strain for the sample. Which of the following gives the Young modulus of the material? It's a straightforward graph. There is stress and there is strain, nothing else. The Young modulus is equal to stress over strain, and the gradient of a graph is also equal to the thing divided on the thing on the y-axis divided by the change in the thing on the x-axis. So it would just be the gradient. So this graph is straightforward. You already know about it. But if like you're given some strange kind of graph and you have to figure out what's the gradient or the area, remember the gradient is always the thing on y divided by the thing on x, while area under the graph is equal to the thing on y multiplied by the thing on x. Because like if you were to find the area under the graph, this is a triangle, so you would be doing 1/2 times stress times strain, right? Like, of course, there are other numbers depending on the shape of the graph, like 1/2 in case it's a triangle, or if it's a square, there wouldn't be a factor like that. But generally speaking, the area is the thing on y multiplied by the thing on x. So here it's just straightforward, it's a gradient of the graph. Question 2. A coin and a feather are dropped from the same height through air. Which row of the table is correct as the coin and feather fall to the ground? Initial acceleration and time taken to reach the ground. Coin is heavy, feather is light. The height is the same. They're falling through air, not vacuum. And we have to talk about the initial acceleration, not the acceleration like in general or at some point, initial acceleration. So, the initial acceleration, because like at the moment you drop the coin and the feather, right at the moment you drop them, both of them are not moving. Their velocity is zero. Anytime you drop something, at the initial moment, its velocity is zero. If its velocity is zero, this means air resistance is zero. Air resistance only acts when something is moving through air. If it's not moving, there is no air resistance. If air resistance is zero, the only force acting on both of them is their weight. And we can assume that we can deduce that they are freely falling, right? If something is freely falling and there is no air resistance, then the acceleration acting on them is g, the 9.81 meters per second squared. Okay, you can only say that this acceleration is there because air resistance is zero. In practical, like, and also because they said initial, right? So there was air resistance zero. But like as the coin and feather will fall down, their acceleration will change because air resistance will come into play. So it's something from option C or option D. Now, about the time. So how do we find the time? Like, you could just say the coin is heavier and will fall faster, right? So its time would be less, and that would be enough to find out the answer. But if you want to go into some physics, so this is the equation. S is equal to ut plus 1/2 at squared. The Suvat equation. Initial speed was zero, so we are left with this thing. if you rearrange it, you get t squared is equal to 2 times s over a. Over here, this a is not the initial acceleration because now we are studying the time taken to read the ground. So it's like the overall acceleration, and the overall acceleration is greater for the coin as compared to the feather. So if that is greater, then the time for the coin would be less. If this is greater, then this is less. So that's how you like can prove it mathematically using some Stewart equations. Uh, and just remember that this part here is overall. That's why I've written this. But since we're talking about the initial acceleration, so it's same for coin and feather. If they just talked about the acceleration, like they did not say initial, then you would say greater for coin. Okay. I hope that's clear. Question 3. A physical quantity can be either a scalar or a vector. Which row of the table is correct for acceleration and work done? Acceleration is a vector. Work done is a scalar. How do, like, you could just memorize that, but why, if you want to know why? Acceleration is like F is equal to ma. Force is equal to mass times acceleration. Force is a vector, mass is a scalar, and the only way to get a vector through a scalar is by multiplying that scalar by a vector. So acceleration must be a vector. Work done. Now you might say, but work done is force times distance, and force is a vector and distance is a scalar. But the difference is, work done is not just simple multiplication. Like, yes, you do that in numbers when you're calculating, but in calculus, you learn about something called scalar product or dot product. So work done is the scalar product of force and distance. And when you take scalar, sorry, not distance, displacement, these are actually both vectors. When you take the scalar product, like this dot here, in between this means it's a scalar product. When you take scalar product of two vectors, the result you get is a scalar. There you go. Okay, question 4. A spring is stretched beyond its elastic limit. Beyond its elastic limit. The applied force is then removed. Which of the following describes the behavior of the spring? It's simple. If you stretch anything beyond its elastic limit, it does not go back to its original shape or size, and it becomes plastic. By plastic, we mean like it's not elastic anymore. An elastic material, when you remove the force, it goes back to its original shape. So, uh, let's look at the options. The extension of the spring is always proportional to the force applied. No, it's only uh, proportional until the limit of proportionality. Like when you draw the Hughes law graph, so it's up till here. After that, it's no longer proportional. Plastic deformation occurs until the spring reaches its elastic limit. Completely wrong. Plastic deformation occurs after the spring reaches its elastic limit. The spring only shows elastic deformation? No, because it's beyond its elastic limit. The spring does not return to its original limit. Yes, that's right. So it's option D. Question 5. An aeroplane lands on a runway at time 0 and then decelerates. The graph shows how the deceleration of the aeroplane varies with time. Which of the following does the shaded area on the graph represent? Same concept, guys, that we did in question 1. If you are trying to find the area under a graph is the two things multiplied by each other. Deceleration multiplied by time. Like generally, randomly, whatever the right word here is. Like, of course, when you do it mathematically, you would have to divide it into two shapes. There is this triangle, so the area of a triangle plus the area of this rectangle. So, but in any case, it would be these two things multiplied by each other. Now, let's just write them in symbols to make this somewhat simpler. So we're basically multiplying deceleration, symbol is A, with time. Now, let's think of the formula of acceleration. The formula of acceleration is change in velocity over time, right? It can also be written as change in time. It's fine. You can write it either ways. So change in velocity is equal to acceleration multiplied by change in time. Whenever you multiply acceleration by time, what do you get? You get change in velocity. So over here, the area represents change in velocity. So option A and B, they are wrong because it's not displacement or the change in displacement. Option C and D. C is velocity, D is change in velocity. It makes a difference here. You can't say velocity because acceleration only happens when the velocity changes. If there is no change, there's no acceleration. So it's option D. I hope that's clear. Question 6. When a force is applied to a spring of stiffness K, the extension of the spring is delta X. Uh, so, okay, we know the formula, Wick's law. Force is equal to spring constant times extension. So K is force over, sorry, extension is force over spring constant. Now, a force 2F is applied to a second spring of stiffness 3K. Which of the following expressions give the extension of the second spring? Um, Now we're trying to find the new extension. Okay, let's call it delta x2. This is a common type of question in like every physics exam in the world. They give you like information, like general information about a formula, and then they change the values. Like they'll tell you the force is doubled or tripled or quadrupled, and then something else also changes, and then how would extension or something change it? So the way to do it is to like write the original formula as I did here. Then you write the new thing, which is we're finding extension. Since the extension would change, so I'm calling it delta x2. So I know the formula, it's force over extension. Now the force is 2 times F. And this is 3, the spring constant is 3 times K, right? But what is this thing? F over K. It's the previous extension. So I get 2 by 3 times the old extension is equal to delta x. So the new extension is 2/3 of the original one. So it is option A. If you understand this technique, you can do any question that, asks you to find something by changing the variables. Question 7. A student drops a ball and measures the time taken for the ball to reach the ground. He repeats this for different heights. He uses a graphical method to determine a value for g, the acceleration of free fall. He plots height of the y-axis of his graph. Which row of the table is correct for the student's graph? So, well, see, they uh they mention that g is the acceleration of free fall. Why are they being so generous? Like, honestly speaking, if a student does not know what is g and they're sitting this exam, they need to rethink why they're sitting this exam because g is something so common in physics. You should know it if you've like taken some like even a few classes. Um, and so he plots height on the y-axis and which row of the table is correct for the student's graph. So we have to say what is on the x-axis and what is the gradient. Uh, what we know that the height is on the y-axis, as it's here, and we need to find what is here. So it's it's an experiment to determine g. This is core practical 1 or 2. I think it's core practical 1, but it's either the first one or the second one. So in that practical, the main formula used is this: S is equal to ut plus 1/2 at squared. Because you're dropping something, a ball here from a height, and it will take some time to fall down. You're trying to find a. Uh, the initial velocity is 0. Whenever you drop something, the initial velocity is 0. So this is the distance. Um, this is the main equation you're using. On the y-axis, you have s. Let's just write the equation for the straight line. Y is equal to mx plus c. So what does this tell you? On the y-axis, you have the distance, the height. On the x-axis, you would have time squared. So one of these. And then what is the slope or the gradient equal to? The gradient here is equal to a divided by 2. Yeah, or g divided by 2 because it's the acceleration of free fall, as it said. So it is option C, time squared and g by 2. Yeah, option C. Okay. Question 8. The velocity time graph for a train journey is shown. Which of the following expression gives the distance traveled by the train in time 2t? Distance traveled? Distance traveled is the area under a velocity time graph because you're multiplying these two things. Remember, area is when you multiply the thing on the y by the thing on the x-axis, and you have to do it for the entire time. So distance here is area under the graph. The area under the graph means all the area that is between the graph and the x-axis. So it's like here it's like one triangle and then 2 squares. So let's start with the triangle. That would be, its area would be 1/2 times the base, which is this thing, d times the height, which is this. It's from v to 2v, so 2v minus v, plus the square now. Its height is v, its length is t, so v times t, plus this square for rectangle, square, yeah, square. Okay, the height, which is again v, and this distance, so 2t minus t. So, what do we have here? Let's just simplify it. Vt over 2 plus Vt plus Vt. So, Vt over 2 plus 2Vt. So, that's like 2 plus 1 over 2 times Vt, and that is like, that is like 4 over 2 plus 1 over 2, guys. I'm sorry, I'm doing such basic math. So that's 5 over 2 times Vt. So it's option D. You know what the worst thing is? Sometimes you do a question like this and you get through all the basic and the advanced math. And when you finally reach the answer, you find out that it's not even in the options. But thank God, I was safe. Question 9. A free body force diagram for an object moving through a fluid is shown. Upthrust, drag, weight. The mass of the object is 5 kg. The object is accelerating upwards at 4 meters per second squared. Which of the following gives the magnitude of the drag force in newtons? Since there is acceleration here, and there is mass, and there are forces, so it leads us to my favorite equation. F is equal to ma. When I first learned about this equation, I used to think that this F is like just force. Like I could just write it here and just use any force, like upthrust 90 is equal to mass times acceleration. But I learned with time that this force is the resultant force. It's not just force, it's the resultant force. What is the resultant? The total force. Like the combined effect of all these forces would be the resultant force. Um, so on the right side, mass times acceleration, 5 times 4. Acceleration is a vector, force is a vector, directions matter here. The general convention is that up direction is positive, downwards is negative. So since the acceleration is upwards, I'm taking it positive. If it was downwards, then with my convention, acceleration would be negative. The resultant force. Now, again, the same convention. Upwards forces are positive, downward forces are negative. So I will write here, upthrust minus weight minus drag is equal to this. Let's put in the values. 90 minus 49 minus drag is equal to 5 times 4 is 20. We can just keep it 5 times 4 because I just looked at the options and they did not solve it. We have to find the drag force. Let's just take drag force to the other side. So we'll be left with 90 minus 49 minus 5 times 4 is equal to the drag force. That is option C. Okay. Question 10. Traffic lights of weight W are suspended from a wire. So here is the weight. The wire is held at an angle theta to the horizontal by 2 supports as shown. Which of the following expressions gives the tension in the wire? So the wire, here are 2 wires, okay? Whenever a wire, a cable, string, they're held tight, there is always tension in them. And tension acts towards the object that is pulling something. Like here, the traffic light is being pulled by the support. So the tension will be towards the support. The tension acting on the traffic light will be towards the support, right? Because we are considering this from the perspective of traffic lights. Let's say if instead I was considering it from the perspective of the support, then the traffic light also pulls the support towards each other. Then I would consider tension in the opposite direction. So like when 2 objects are connected by a string and it's tight, they both pull each other. But you have to think from the perspective of the object you're considering. So here it's a traffic light, so we are considering the force acting on the traffic light. So that would be tension towards the support, both of them. So we have to find the tension. So there are forces and they're acting at angles. I love such questions. What you have to do here is to resolve them. Whenever a force is acting at an angle, resolve it. So, here there's an angle. I'll draw a horizontal line here just to like, you know. Now, by some math rules, if this angle is theta, then this angle, I think it's called alternate angles. So at this stage, I know like all the math formulas or theorems, but I've forgotten their names. So yeah, I think it's alternate angles. Um, so whatever this angle is, this angle would be the same. If it's 30 degrees, then this would be 30 as well. So similarly over here, if this is the angle, this would be the same angle, right? Now, let's resolve them. Remember how to resolve forces. You just complete the triangle. There would be one force here, horizontal, along the x-axis, one force along the y-axis, and look at the directions. The directions are very important. If you mess up the directions, you mess up the question. So, how do I know they point this way? So I know the tension is going in this direction. Now, using the head to tail rule, the first component, if it is to the right, the next component will be upwards. And that makes sense. But like if let's say I drew the first component to the left and the other like this, that would be wrong because you can't join the tails of the two components. Or if I, let's say, drew the first component to the right, but drew the next one like this, that would again be wrong because it's head to tail, head of the first component to the tail of the second. Now the component that is adjacent to the angle, next to the angle, that is always the cosine component. So this is t cosine theta. The component that is opposite to the angle is always sine, so t sine theta. Some students memorize it like this. If it's horizontal, it's cos. If it's vertical, it's sine. That can be true sometimes, but not always. That's not the rule. The rule is if it's adjacent to the angle, it's cos. If it's opposite to the angle, it's sine. Same thing on the opposite side, except the directions. Now the tension is here, and the angle is here. So again, head to tail rule. This is the first component, and this is the second, head to tail. So t cos theta and t sine theta. If you've resolved it, you've done something really great. Like, see, physics is all about learning very small steps. If you know those small steps, you can solve like really difficult questions. Um, now, but let's look at the horizontal forces. Forces have direction, so you have to think horizontal and vertical. Okay. Horizontal forces first. There are just two horizontal forces. There's tension cos theta and tension cos theta, but they're both acting in the opposite directions, right and left. And they have the same amount because they're both t cos theta, so they cancel each other out. So let's forget about that. Weight, uh, weight and t sine theta, they are the vertical forces. T sine thetas, they're both upwards. Weight is downwards. Again, using the convention, up is positive, down is negative. Let's write the equation F is equal to ma. But here there is no acceleration because the traffic lights are suspended. So they are at rest. So they are in equilibrium. Like there is no resultant force acting on that. So acceleration is zero. And this is a resultant force. Now, what is the resultant force? t sine theta plus t sine theta, they're both upward, minus weight, which is downwards. And you then just rearrange it. So 2t sine theta is equal to weight, and t is equal to weight over 2 sine theta. So that is option B. There you go. So we're done with section 1. We'll move on to section B in the next video. Let me know if you guys have any questions or suggestions in the comments below. Please like, share, and subscribe. And if you want to learn with me, if you want tutoring services with me, you can check the physics and English tutors link on my channel. There are some videos. I'll also put it below in the description. And you guys can book some classes with me. So all the best for your exams, guys. See you in the next video. Bye.